I hear the train a-comin', it's rollin' around the bend, and I ain't
This
seen the
week's
sunshine
problem of the week
since I
makes
don't
its
know
nearly
when.
annual visit to the world of train problems. Who can forget several years ago when a fly was involved with two locomotives that were unfortunately traveling towards one another on the same track? And who can forget last year when the problem was sponsored by the film Unstoppable and it involved a commuter train between Middleton and Centerville? And then 2 years ago, there was a problem with a train going through a tunnel in a mountain, and it was very similar to the one we're working this week. And then there's this.
At 7:30 a.m., an express train traveling 60 miles an hour leaves Santa Fe bound for Phoenix, 520 miles away.
Shh! Visualize it, Bert.
At the same time, a local train traveling 30 miles an hour and carrying 40 passengers leaves Phoenix bound for Santa Fe. It's 8 cars long and always carries the same number of passengers in each car. An hour later, the number of passengers equal to half the number of minutes past the hour get off, but 3 times as many plus 6 get on.
Let's get on with this week's problem. The key to the problem is that the length of the bridge is exactly half the length of the train. And another key is that if a train is traveling 60 miles per hour, that means it goes 1 mile every minute. So the front of the train goes across the bridge, and if it's a 2¼ mile bridge, it takes 2¼ minutes to go that far. And then the middle of the train has to travel across the bridge, another 2¼ minutes. And now there's just the back half of the train, and it takes yet another 2¼ minutes, and the train is all the way through. We add it up, we get 6¾ minutes, but we were instructed to convert it to seconds, and we do. 405 seconds, the answer to this week's problem of the week.